What makes your heart beat? Seems like there's a simple solution, right? Well, kind of, but so much goes into one single heartbeat, and your heart is beating about 100,000 times in one day. That's about 35 million heartbeats in 1 year. This is what our heart looks like. It's made up of 4 separate chambers, 2 atria and 2 ventricles. The atria are connected to the ventricles through valves. Blood is pumped through the heart when the atria and the ventricles contract and relax. But let's get into a little more detail and focus in on our question. What causes the heart to beat? First, let's point out 2 nodes, the SA node, also known as our pacemaker, and the AV node. When blood is pumped into the right atrial, the SA node, or the pacemaker, is triggered, sending an electrical impulse into both atria. This impulse forces the atria to contract and push blood through the valve and into the ventricles. During this process, the atria will then relax and the AV node is triggered. The AV node will then send an electrical impulse into each side of the ventricles, forcing the ventricles to then contract and force the blood outside of the heart. At this point, all chambers are relaxed, and the process will begin again. So what happens if someone's natural pacemaker is not triggering correctly? Their heart may be beating too fast, too slow, or irregularly. A doctor may implant a mechanical pacemaker in order to control the heart's rhythm. It will send an electrical charge to the SA node we talked about earlier and force the heart to beat regularly. We mentioned an object called a mechanical pacemaker, something that will keep the heart beating regularly. But how? Let's focus in on 3 main questions. How it's made, how it functions, and how it's implanted. Here we have an image of a mechanical pacemaker. First, let's talk about how it's made. All mechanical pacemakers are composed of a battery, lead wires, and circuitry. The battery and the circuitry are located in this center region, also known as the generator. The lead wires are attached to the generator and then connected into the heart. The first component we will discuss is the battery. The battery is made to store enough energy to stimulate the heart with a jolt of electricity when it is not beating properly. It also provides power to the sensors and is required to generate up to 5 volts. The battery is made up of 2 metals that form the anode and the cathode, which are the battery components required to transfer energy. The next component we will talk about are the lead wires. Since the lead wires are made up of a conductive material, they allow the charge to flow. The main property of the lead wires is designed to carry electricity between the battery and the heart. This is why the lead wires are connected from the generator and implanted into the heart through electrodes. The last component of the pacemaker we will discuss is the circuitry. It is also known as the control center. It is composed of 4 units: the resistors, which are made to slow down the amount of flow charge; the capacitors, which store the charge and reuse it later; diodes, which allow the flow of the charge in one direction; and semiconductors, which are solid substances that conduct electricity. Since these semiconductors have been made, pacemakers have been able to be developed much smaller, which make the implantation process easier. Now that we have discussed how mechanical pacemakers are made, let's jump in to how they function. We know that the battery and the circuitry are located in the generator. So when the heart is beating irregular, the sensors pick it up and send a signal to the generator to initiate evenly timed electric shocks. This electrical impulse sent through the lead wires will trigger the SA node we talked about earlier into beating properly to get the heart back on rhythm. We have discussed how a pacemaker is made and how it functions, but we have not talked about our last question, which states how a pacemaker is implanted. Here, we have a pacemaker located right below the skin above the collarbone. The lead wires, are attached into a vein which is also above the collarbone. This vein extends into the vena cava, which attaches to the right atrium. The lead wires are then attached to the side of the right atrium, and the other lead wire is sent through the valve and attached to the side of the right ventricle. On the tips of these wires is an electrode which picks up the electrical signal sent from the generator. Here we have a mechanical pacemaker. We know this region is called the generator, and inside it is the battery and the circuitry. This is my dad, George Gladden, who has chronic atrial fibrillation. He has a pacemaker located here underneath the skin below the collarbone. If you zoom in closely, you can see the lead wires as they extend into the vein also above the collarbone. Now you know how a heart beats and how science has allowed us to develop a machine, the pacemaker, to regulate a heartbeat and all the physics behind it.